Hey guys, Miss Miklos here, and today we are going to be talking about the Chapter 4 review. So I'm just going to go through a few problems on each concept. The first one, just making sure that we know how to use our calculator. And there are really 4 different types of problems that we're dealing with, and the first thing I need to be aware of is the mode on my calculator. So remember, if we press mode, if we see that degree symbol or if our answer should be in degrees for angles, we need to make sure that degree is selected. If radian should be selected, then we need to make sure that that's highlighted. Okay, so first thing I would do in your calculator is make sure that you're in degree mode. Now, this first problem we're looking at right here, this is a problem where we have the angle, we are trying to find the ratio, and cosine is a button we have on our calculator. So I'm going to press cosine and then type in 25.2 and I get 0.9048. And whenever I have cosine, sine, or tan of an angle, this is exactly how I would go about doing it. Now our next problem is a little bit different because we do not have a cotangent button. However, I know that cotangent is the reciprocal of tangent. So I'm going to press 1 divided by tan and then type in 41.8 degrees. Because what we are really doing here is we are taking the ratio, we're taking the reciprocal of this ratio. And I get 1.1184. Often it will ask us to round to 4 decimal places after the decimal point for all ratios. So anytime that I'm looking for a ratio, I'm going to use one of these 2 methods to go about solving. Now moving on to our third problem here, this time I'm trying to find an angle. And it's nice because we know we have a sine button on our calculator. So I'm going to go ahead and type in sine inverse. And the way we do that is by pressing second sine, and then I'm going to type in my ratio. And I end up getting 43.6 degrees. So when we're trying to find the angle, this is what I would do for sine, cosine, and tangent. Obviously, cosine I would press cosine inverse. Tan I would do tan inverse. Our last option that we're going to deal with is when we're trying to find the angle, but it's a button that we do not have on our calculator. So I need to think, what is the reciprocal of cosecant? And I know that it is sine. So I'm going to use sine inverse, and then I need to do 1 divided by and type in whatever our ratio is. Once again, this is because I'm taking the reciprocal of this ratio. I end up getting 25.8 degrees. So this is something you guys definitely want to make sure that you know how to do. I think these are some of the easiest questions on the multiple choice portion of this test because it's really just putting it straight into the calculator. There's no finding sides of triangles or anything like that. I'm just testing a basic skill. Next major concept we're dealing with is determining the quadrant that something lies in. Okay, so just kind of a reminder, we know that it's quadrants 1, 2, 3, and 4, and this is 0 degrees, 90 degrees, 180 degrees, 270 degrees. We can also think of it in terms of radians. So we have 0, I have pi over 2, I have pi, I have 3 pi over 2, and this is also 2 pi. It is also 360 degrees. So our first problem here, determine what quadrant 6 pi over 5 lies. There's a few different ways I could do this. I could think of the fact that this is 1 and 1/5 pi, and we talked about how pi represents a semicircle. So one semicircle would take me to here, then 1/5 would be somewhere over here. So I know that this angle would be somewhere here, which would give me quadrant 3. Now the other way I could go about doing a problem like this is by converting it into degrees. And I would do that by multiplying by 180/pi. And I get 216 degrees. And I know that 216 degrees is between 180 and 270. So once again, I would get that that is in quadrant 3. Okay, so I don't care which way we go about thinking about it. The important thing is just knowing what quadrant it is in. The other type of question we'll see like this, and we did a lot of these in class, in which quadrant is tan negative and cosine positive. So we went through a bunch of stuff and we kind of talked about all students take calculus. So I know tangent is negative in quadrants 2 and 4. And cosine is positive in quadrant 1 and 4. So I'm looking to see what quadrants do those overlap. And that's telling me that quadrant 4 is the only quadrant where tangent is negative and cosine is positive. So all means all trig functions are positive. Students means sine is positive. Take means tan is positive. And calculus means that cosine is positive. We also have a lot of problems on our test that deal with finding the exact value. So number 1, it says cosine of negative pi over 6. And once again, there's a few ways we can go about doing this. My guess is that a lot of you might convert this into degrees. And I actually get that it is negative 30 degrees. Okay, if I wanted to make this into a positive value, I could add 360. Which gives me 330 degrees. So if I'm drawing this out, I know that that is in quadrant 3, and it is 30 degrees away from the x-axis. I know my special triangle tells me opposite from 30 it would be negative 1, my adjacent side would be radical 3, and my hypotenuse would be 2. So this is definitely one of those two triangles we need to have memorized. I know cosine is adjacent over hypotenuse, so I'm going to say my answer is radical 3 over 2. And before I give that as the final answer, I just want to double check. Does it make sense in quadrant 4 that cosine is positive? And it does, so I know that this is my final answer. Let's do one more like this. This time we have cosecant of 225. I know 225 is in quadrant 3. And that is 45 degrees away from the x-axis. So my opposite side is negative 1. My adjacent side is negative 1. And my hypotenuse is radical 2. I know cosecant is the reciprocal of sine. And I know sine is opposite over hypotenuse. So cosecant has to be hypotenuse over opposite. So I end up getting radical 2 over negative 1, which is negative radical 2. And let's just check for a moment. Does it make sense in quadrant 3 that sine and cosecant would be negative? And it does. So I really want to stress how important it is to double check that every time because it could be that maybe negative radical 2 isn't an option and only radical 2 is. We just need to make sure that we are putting down the correct answers. We also have some problems here that just give us a right triangle. And on this one, they're asking us to find the angle theta. And so if we look, it looks like I have the opposite side and I have the adjacent side. So I'm going to use tangent because I know tangent is opposite over adjacent. Now, just like we practiced earlier, I know when I'm finding an angle, I need to use tan inverse, and I'm going to put 4 divided by 7 into my calculator. And I end up getting that theta is equal to 29.7 degrees. And that would make sense that this angle is smaller than this angle because 4 is smaller than 7. Here's another type of problem we will see where it's only going to ask me for a single trig function. And before I can find cotangent, I need to find this third side because I know cotangent is adjacent over opposite. So I'm going to go ahead and use Pythagorean theorem. And I end up getting a squared plus 16 equals 25. So a squared is 9. So a is equal to 3. So I know cotangent is adjacent over opposite. So my answer here would be 3 over 4. So it's really important we know what the reciprocals are, and to make sure that we are using Pythagorean theorem correctly. Now let's get into some word problems. Okay, and these word problems are similar to what I would expect you guys to be able to do on our actual test. So this one tells us that we have a ladder that is leaning against the side of a house. Okay, so there's my ladder. It tells us the base of the ladder, which means the bottom, is 5 feet away from the wall, and it makes an angle of 39 degrees with the ground, and we need to find the length of the ladder. So based on this angle here, 5 would be the adjacent side, and the length of the ladder would be our hypotenuse. So I know that cosine deals with adjacent over hypotenuse. So I need to isolate x, so I'm going to multiply both sides by x, and then I'm going to divide both sides by cosine of 39 degrees. And I'm going to go ahead and put this into my calculator, and I end up getting x equals 6.4 feet. And it would make sense that 6.4 is longer than 5, and I know the hypotenuse has to be the biggest side. The next word problem I want to go through is similar to something we did in our notes, where we have a school, and then I have a flagpole, and it tells me from a point that is 100 feet away that the angle of elevation to the top of the flagpole is going to be 39 degrees, and the angle of elevation to the base of the flagpole is 28 degrees, and we want to find the height of the flagpole. So the way that I can find this height is by finding this whole opposite side and subtracting this opposite side from it. So I'm going to go ahead and use tangent, and I'm going to label this side here y and this entire length z. So I would say tan of 39 degrees equals z over 100. So I'm going to do 100 times the tan of 39 degrees equals z. I get 80.978 equals z. Remember that I want to leave that in its complete form until I'm completely done, because I don't want to round too soon. It could cause me to have an incorrect answer. I'm doing the same exact thing here with finding y, which is this length. So this time I'm using 28 instead, and I'm going to go ahead and put this into my calculator, and I get 53.171 is y. So now I need to subtract these two values from one another, and I end up getting that 27.8 feet is the height of the flagpole. So this whole concept where I have two different triangles is something that I would expect you guys to be able to do on our test. In fact, I think the toughest word problem is really similar to this one. The last word problem I want to go through, I want to do because it is talking about an angle of depression. Okay, so there we have a building, and here's like where the statue is. I know my statue is lovely. I know an angle of depression goes out and down, and it tells me that the angle of depression is 72 degrees. It tells me that this length right here is 49 feet, so I know that this is 49 feet, and we're trying to find the height of the building, which this length of the triangle is exactly the same as this. So this would be my opposite, and this is my adjacent. So I'm going to say tan of 72 degrees equals x over 49. So in my calculator, I'm going to do 49 times the tan of 72 degrees. And I end up getting 150.8 feet is the height of the building. And that would make sense because I know this length is definitely larger than this length because this is opposite from 72 degrees. 49 feet is opposite from a smaller angle. Final concept that is on our test, and this is both on the multiple choice and on the part that you're doing by hand, is graphing trig functions. So remember, we need to know these characteristics. So I have y equals 2 sine 3x. Our first characteristic is the amplitude, and remember the amplitude is always the absolute value of this coefficient, which means it's always positive. Our second thing that we need to find is the period, and the way we find the period is 2 pi divided by our b value, so in this case that is 3. Lastly, this one is no flip because I know that 2 is positive. So I'm going to show you guys the minimum amount of work I would need for you guys to graph 2 full periods of this. I know I need to go up 2 and I need to go down -2. And I have 1, 2, 3, 4. And I'm going to label that 2 pi over 3 because that is the period. And to the left, I'm also going to go out 4. And I'm going to label that -2 pi over 3. I know sine always starts at 0, then goes up to the amplitude, then 0, negative amplitude, 0. Working backwards, I'm going to go negative amplitude, 0, amplitude, 0. So when I sketch this, this is what it would look like. Okay, notice what I need to see. These are the labels on the y-axis. These are the labels I would need to see on the x-axis. I got this because that was the period. Next one is a cosine one. However, our characteristics are exactly the same. So our amplitude is the coefficient, and it's the absolute value of the coefficient, which is 1. Our period is 2 pi divided by b, which in this case becomes 4 pi. And this one has no flip. So when I'm graphing it, once again, I just need to go up 1 and down 1. And I'm going to go 1, 2, 3, 4, and that's 4 pi. And I'm going to go to the left 1, 2, 3, 4, and that is -4 pi. I know cosine always starts at our amplitude, and then 0, negative amplitude, 0, amplitude. And I'm going to fill in working backwards, and I'm going to sketch what that curve would look like. And this is what I would need to see from you guys to get full credit. So I would need to see that you understand the period. These labels right here are not necessary. Last but not least, I have a tangent graph. And the way that we find the amplitude is exactly the same. The amplitude here is 2. The reason why it's 2 and not -2 is because it is the absolute value of that number. The period, though, this time is different because it is pi divided by b, which in this case is just pi because our b value is 1. Remember, sine and cosine, it is 2 pi divided by b. The third thing, this time we are flipping it, so I'm going to write flip. Okay, now on my graph, and some of you guys struggled with this on the quiz that we just took. Okay, I'm marking the period, but I know the asymptote is halfway between the origin and the period. Okay, so I'm just going to go ahead and sketch that. I'm even okay if we don't label where that is. I just need to be aware that that is halfway between the origin and the period. Now, I also need to label 2 and -2. Tan, I know, always starts at the origin. And since the amplitude is 2 and it's flipped, halfway between the origin and our asymptote, I'm going to go down 2 and to the right one, and I'm also going to go up 2 to the left one. So this is a sketch of what my graph would look like. So I went ahead and I graphed 2 periods of this tangent function. Okay, so this is just a good quick review of graphing sine, cosine, tangent. You guys definitely have more examples if you need extra practice on that. Hopefully this kind of summed up everything that I expect you guys to be able to do on the test. Please make sure you talk to me if you have extra questions on stuff, and study and do your best.